Sridhar, so how will I record? Can I record the screen?
I have started the record on GoToMeeting.
Okay, so you'll be recording, right?
Yes, sir.
Okay, fine, sure. Thank you so much. I don't know why there's a problem with my laptop. Just an update there. It shouldn't have been. I mean, it's not allowing me to log in as MCAL global presenter.
That's interesting. Um, so you have to
Anyways,
log
we'll
in. We are able to
figure.
see your screen.
Okay, perfect then. We'll carry out with the class then, and then after the class, I'll call you, Sridhar.
All right.
Let's see what we can do to fix it.
Sure. All right. Go ahead, guys.
Okay.
Okay, thanks, Sridhar.
Okay, sure. Okay, so guys, how are you? Sorry for the little technical difficulties. So I think we had a little bit of wastage of time, so we'll make it up for it. So today's agenda for the class is natural language processing. We'll give a brief introduction of what it essentially means to, how does NLP help in machine learning, and why is NLP essential to learn? And tomorrow we will see the aspects of deep learning. So this will just be wetting our feet in these concepts. Will not go into too much of detail, but if you are interested to know more, so we will be launching separate courses on these two topics. So let us start with NLP for today, and let me start with the basics. So what we have seen yet till now, that we were dealing with something called a structured data, right? So we were dealing always with an Excel file. So if someone was giving me an Excel file, I was to some bit of my understanding, I was cleaning the data, I was calculating the summary statistics, then I'm fitting a model, then doing cross validation, and then finding the predictions. So that was what I was doing till now. But everything involved will not be present to you in an Excel sheet, right? So there can be images, there can be photographs, videos, there can be texts. So data is everywhere, right? So if you pick up a newspaper, right, you take a photo of it, the data of the newspaper is present in an image. Okay, so it's not available in an Excel sheet, right? Either you have someone who can write down that in an Excel file and then you fit your model, or you have to be smart enough to directly use that data for your own your own benefit. For example, the autonomous cars. How do autonomous cars self drive, right? So they're not present with an Excel sheet that these are the possible cases and then you take a left or right. They take the data in live, and they take it from the radars, the sensors, the images, and they process it on live. So there's a host of data that is coming through different sources in different forms. So the essential thing that comes into picture is that your data will not be always in structured format. There will be multiple different types of formats that the data can flow in from. Okay, now so unstructured data essentially can be in the form of text, images, videos. Okay, so let us constrict our imagination to these three essential categories where you can have your unstructured data. Images is a little bit easier to handle because if you know that all images would be made of pixels, right? So every image is a three-dimensional data point of red, blue, green. So an image, for example, will be represented by pixels. Or so for example, the RBG, the range is between 0 to 256. So basically a three-dimensional matrix of these numbers will be an image. That is still structured, right? It's a little difficult to extract that. It's not very simple to extract that, but still it is numbers. Videos also has like frames, right? So videos can also be associated with numbers. So basically frames of images is a video, right? But the difficult part here comes is the text. A text cannot be associated to a default number, right? What number can you give to army? What can you number can you give it to navy, right? If I say army is 1, r is some, let's say the number of the nth letter of the A to Z alphabets. So, but will that really make sense, right? It doesn't make sense. A is the first alphabet, Z is the 26th alphabet. There's no logic behind it, right? Someone has already given you, and there's no logic that Z is 26 times of A, or Z is Z minus A is 25. It's not that, right? So the difficult part in text analytics comes into picture is that you don't have associated numbers to the text. Okay, so NLP, the first part is to associate numbers, or how do we represent text in form of vectors. So vectors, if you would, if you remember that, like, let's say your X and Y was there, right? So let's say X was the income feature, Y is the age, right? So an income corresponding to this age is a vector. Okay, so income was, let's say, 20,000, age is, let's say, 26. Okay, and on the basis of that you have a vector of features. How would you represent a vector of, let's say, Indian Army? So let's say you have a document of a news document, right? So let's say the number of the news article says that the crime in India has increased by 26% from last year. The police and the courts are trying to devise a method where you can decrease the number. Now, how would you represent that information in form of vectors, right? So the process that essentially does that is called word embeddings. Okay, now what are word embeddings? Word embeddings is basically each word is associated a score. Okay, so for example, let's start with the first type of word embedding called the TF-IDF. Now, before I start with TF-IDF, I want to give you an essence of how we pre-process the analytics. Now, let's try a document. Okay, so let's say a document 1 has sentence: I go to school at 7 a.m. in the morning. My father drops me to the bus station. Okay, there's another doc, let's say doc 2. Okay, let's say in that you have my friend Mitesh is an architect. He designs amazing buildings. Okay, now there are two documents here. How will you represent these two documents into different features, or let's say how will you represent this document as different vector of words? Okay, so let me take an example. You have Google. Okay, you enter a query here. So let's say you want to search about MCAL. So you write MCAL courses offered in Python. So for example, you enter this query and Google will have a host of documents, right? So there will be many documents in form of text, images, everything will have all sorts of data Google will be having, right? So how will it find these particular words from so many, like if you have seen whenever Google searches and completes the search, it will give you these many results found out of these many so 1 of 10 results displaying out of whatever the number is. So there are let's say infinite number of documents present in Google's database. How will it find these what do you call words and give you the most optimum or the best search possible out of the infinite database it has? So this process is called information retrieval. Okay. Okay, any doubts still here? I'm open to questions. Are you getting the essence of it? What we are trying to see?
Basically,
Yes.
not an issue. So basically, it seems we want to create a sentence which has a meaning.
Which has some meaning
basically,
mathematically. So for example, if this is an example of document. Now I want to I asked you, let's say, what does Mitesh do? Okay, so what you'll do first, you'll search these words in document 1, you'll get a negative. Then you'll search these words in document 2, you'll get a positive. Mitesh, what does Mitesh do is not a direct question, is not directly present, so you have to understand the context. So we'll slowly get there in how your text's context can be interpreted and your answers can be derived. But to an essence, you are kind of trying to match where is Mitesh present, and according to that you can answer the question, right? So you can, if you were Google, you could give me doc2 as a result, right? So if you have entered what does Mitesh do as a query, then you will give me doc2 as a feedback to me. So I would be very happy because I got the information from here. But imagine if there are in 100 documents containing Mitesh, having the name of Mitesh, and every document is having different information. So for example, this is one of the documents which says that Mitesh is an architect. Then there will be another document which says Mitesh is 6 foot tall. There will be another document which says Mitesh is like Mitesh loves his family. He has 2 daughters. He has 1 wife. So, I mean, there are hundreds of documents that can be from containing the word Mitesh. How do you refine that? How do you say what does Mitesh do should return doc2 instead of all those 100 docs? That is the art. That is the art of natural language processing. That is what you give intelligence to the words. You give intelligence to your query so that it returns the best documents possible from the host of other documents. Okay, so is do you it's understandable that these are things which are very new, and it is completely different from what we have been doing for the last last 1 month or so. So it is a little different, but essentially natural language processing is the art of giving intelligence to words. And how do you give that intelligence is using numbers and the process called word embeddings, which we will come to this. But are you getting this concept, what we are trying to do here?
Yeah, yes, Shubdeep.
Okay, okay, amazing. Okay, so now before we go to the slides, so the process of information retrieval is basically given some query, you are giving out some documents which are closely related to the query. Okay, so this is the process of information retrieval. Okay, now how let's start with word embeddings. What are the word embeddings? So let's take these documents. Okay, so these documents, what I do is I form something called a binary matrix. So let's say document 1, first of all you take all the documents and then you take all the words in the documents as features. Okay, so for example, I will be one feature, go will be one feature, to will be one feature, school will be one feature, like this, all the words including document 1 and document 2. So from I to, let's say, buildings. Okay, so all these will be features. Okay, now what is the vector of document 1? So it is constituting of these words, right? Now, so 1 1 1 1, like this, and all the words that are coming from the document 2, these are all zeros. Okay, similarly document 2 will be 0 0 0 0 0 and 1 1 1 1. Now do you get this? So your document 1 will be a vector of 1 comma 1 comma 1, like this, to 0 comma 0 comma 0. Document 2 will be a vector of 0 comma 0 comma 0, 1 comma 1 comma 1. Okay, so this is a vector of document and this is a vector of document. Now for example, this is the most simplest representation of a document word embedding. Okay, simply whether that word is present or not. If it is present in that document, I signify that with a 1. If it is not present in that document, I signify that with a 0. Very simple form of representation. Okay,
Okay. Yeah.
so for example, let us give you the analogy where you were doing with your what you were doing with your machine learning. For example, you had so many observations, right? So many rows, 100 rows, and then you had features like, let's say, income, height, weight, and all these things, right? Remember? So what was person one, what was the vector of this? So income may be 20,000, height may be 6 feet, weight may be 70 kgs. So person one's vector was 20,000 comma 6 comma 70 comma blah blah blah. Okay, similarly p2's vector will be 40,000 comma, let's say, 5.5 feet, 40 kgs, like this. So p2 person's vector is 40,000 comma 5.5 comma 40 kg, right? So instead of these numbers and instead of these features, what we are doing is we are representing p1 as document 1, right, and the features as the words, and instead of these numbers we are just marking them whether they are presently 0, or I mean whether they are present with the 1, or if they are not present with the 0. Does this representation feel okay? I mean, do you think it's good or it's bad? What are your views here? Any answers? Any feedback how do you think that is this binary representation helping you, or is it like meaningful?
Yeah, it is good, but whole row, how do you think, like, how do you mention that it's specify that it says 1, like whole row P1, whole vector P1 as 1? Like if
No,
I,
no, not P1. Just see the document 1. So what is document 1? It is let's say
if I ask
represent.
you for 15 P1 with 55 kg, then
Okay.
so does it will return 1 for P1 in document?
Okay. No. So what I was telling you was an analogy here. So
Yeah,
P1,
the
P2, like,
example, okay.
yeah, P1 and P2 is like, so for example, if you wanted to ask the what is the weight of P2, right? You can say 40 kgs, right?
Mm-hmm.
But here you cannot say what is, you can just say here that if the word school is present in document 1, or is it present in document 2, or is it present in both?
Okay.
Okay, so here it only marks whether it is present or absent. The words are present in in the document or absent in the document.
Okay, got it.
Got it?
Good.
So there is no particular value that we have assigned. So for example, school is not 70 or school is not 60. We'll come to that slowly. But this is a basic, very basic representation, the binary representation, whether it is present or absent.
Yeah. Okay.
Okay. Okay, just give me 2 minutes. I'll just drink some water. Just give me 2 minutes. Yeah, so I'm back. Anyways, now did you understand the essence, what we are trying to do here? Any questions?
Yeah.
So if your screen is not shared,
Sorry?
we can't see your screen now.
Oh, okay. Yeah. Okay. So can we move on then?
Yep.
Okay, amazing. So now what we have seen is how we can represent documents in terms of vectors, right? That we have seen. So what we were doing, we were just doing the binary vector, whether it is present or absent. Now, can anyone tell me what is the disadvantage of having a binary vector? I mean, if I just tell you that this document has this word and the other document doesn't have this word, how does this help you or keep you as at a disadvantage of let's say information retrieval? If I want to, let's say, considering that these are the two documents, okay, now I enter a query, what does Mitesh do? Which document will come up? Document 2 will come up, because it will search what is not there anywhere. The does is also not there in any other document. Mitesh is there in this document. Do is also not there in any of the documents. So Mitesh will come up from this document. So if I enter a query of what does Mitesh do, the computer will return me document 2, which is good, right? For our all purposes for right now, it is good. But for example, if you have a document 3, which is says Mitesh is very fond of chocolates. Let's say you have a document 4, which says Mitesh has two children and lives with his parents, right? Now, for example, I again ask question, what does Mitesh do? So what is not there in either of the documents? Okay, does is also not there. Mitesh is there in document 2, document 3, and document 4. So my computer will now tell me document 2, 3, 4. How will I understand what does Mitesh do? It has not answered me the question. It has written me set of documents in which all the information about Mitesh is there, right? It doesn't help me. So the disadvantage here is it is only giving me whether the word is present or not. So whenever I ask a question, it will only tell me the documents where this word is present. It will not tell me any context. Okay, so it is not telling me what Mitesh does or what is his hobby or who lives with him. There's nothing. This not telling me anything. So the next thing is called the TIFIDF matrix. Okay. So let's come back to the same thing. You have documents. Okay. Now, all the words comprising of all the documents is called the corpus. Remember this term, right? All the words combined in from all the documents is called the corpus. And so the words within that corpus is called the vocabulary. Okay. So for example, now what TF-IDF means is T means term, F means frequency, I means inverse, D means document, frequency. So it goes one, let's see for the first term. What is term frequency? So let's say my doc is let's say Sunil attended PML. He loved the concepts. He is going to apply them in his job. Okay. Let's say okay, apart from his job is essentially of a data scientist. Okay. Now, let's say I have another doc. Let's say Sharad loves traveling. his job is. Now, carefully see these two documents, right? There are certain words which are common. Let's say data scientist, job, correct?
Love.
Traveling, loves, okay? Who is a data scientist? These two, both documents will come up, which is correct one, okay?
It is showing a message. The organizer is experiencing technical difficulty. As the organizer rejoin, the meeting will end in 5 minutes.
Oh, I think
that's your network connectivity, I guess. We are not getting any message.
Oh, okay. Sorry. I think it's mine. Okay. Sorry.
No problem.
But the organizer, I think, is Sridhar. So maybe, okay, anyways, let's see. I also didn't get any message. Anyways, so what we essentially do is we have to understand what are the characteristic words of the document which represent the document well. Now, if I say data scientist is present in both documents, right? It is not a characteristic word of these documents. So for example, you already know that both are data scientists. So if you enter the who is a data science, both documents will come. Now if I ask you who loves his job, okay, so who loves his job, that is where you have to think that which are the characteristic words of the document. Now let me explain this in a better way. Okay, now how will I explain this? So for example, you run a query on Google, okay? You write a query on Google. So query is basically what you write for a search, right? So let's say best movies of 2018. Now, if I see individually, if I see these terms individually, best movies of 2018, so there will be hundreds or thousands of documents containing the word best. There will be thousands of documents containing the word movies. There will be thousands of documents containing 1 lakh documents containing the word of, and there will be many documents containing the number 2018. How do you combine? So the combination will be and, right? So you want a document which contains all these words: best movies of 2018. So this will be a combination of all these words. So you have to find a document, or you have to find a file which contains all these words, right? So this will be an and, right? So you should present all the words in the query, should be present in the document. Now, if you find all these documents, how will you rank them, right? So there will be, let's say, hundreds of documents that will come out from this query. How will you rank them? What will be the importance of each of the documents? That's where the term frequency comes. So if best, the word best is coming, let's say 100 times here, only 2 times here. Movies is coming, let's say 20 times here, only 5 times here. So you will see that document 1 is more probable to be by more important document compared to document 100, because the occurrences of these words are much more in document 1 compared to document 100. I I'll be open to questions here, because I know it is a little difficult thing to understand. I'm open to questions here. Are you getting the essence of it?
Yeah, I'm okay. Others.
Sunil?
So, yeah, does this sequence make any sense or not? I mean, the same query I can write as like 2018 movies, like
Correct.
by best people. I have just changed the sequence, but meaning can be changed.
Correct. Very good. That's a very good observation. So we have not come up to that word embedding where the sequence is also taken care of. Right now, first we started that a single word will be present. Next, we are starting with multiple words should be present. Now we are seeing that the importance should be according to the number of occurrences of these words. You made an excellent observation that sequencing is not present here right now, right? So we'll come to that slowly.
Yeah, one more thing basically. Assuming first document base has come 10 times, movie 5 times.
Okay.
In the second document, base has
Yeah.
come 5 times, movie 10 times.
Correct.
So just I'm changing the base 10, movie 5, next document 5 and 10.
Correct.
So which document will come first?
Exactly. So right now, according to the logic, both documents will be of the similar importance, because their score is 15 and here also it is 15. So right now they will come with the same. We haven't talked about how to differentiate these documents till now. Right now what we are doing, we are just calculating term frequency. Okay, so term frequency is best is 5, movie is 10. The next one is movie is 5, best is 10. Oh, sorry, I think I told the same thing. Movie is 10 and best is 5. Anyways, and the score total for these two documents are 15. So for you right now, according to the term frequency logic, both the documents are of the same importance. Do you get this?
Yes.
Or are you not comfortable with it right now?
No, this is simple concept. Just we have created a matrix and we are getting the count of the words present there.
Correct. Excellent. That is what. So for example, right now how your matrix will look like. So this will be doc 1, doc 2. Let's see this one. So all your words will be in, let's zoom this in.
So but that binary matrix will help me here, because in binary matrix we are not keeping any count.
No, that's what I'm saying. That's what I'm saying. That's why we are creating a new matrix. Okay, now see, what we have done is we have created a new matrix of the documents, doc 1 and doc 2. And now what we'll do, instead of just telling me Sunil is present as 1, I will now tell you how many times Sunil is present. But for here, for this doc, it is only present once, right? Sunil is only present. So for example, let's say I write here Sunil is going to apply them in his job. Sunil's job is essentially of a data scientist. So how many times Sunil is present? 3 times, right? How many times attended is present? Attended is present only 1 time. Okay. PML present is 1 time. Similarly, Sharad is present. How many times in doc 1? He is present 0. So all the things that are of the document 2 coming from those documents, it is 0. Now, similarly, document 2, Sunil is present 0. Attended is present. Attended is 0. And Sharad is present once. Scientist is present once. I think loves is present twice. Okay, so loves is present twice. Now your new matrix is according to the term frequencies. It's not only just binary 1 or 0. Now it is giving you the number of times. So if there would be another document, let's say document 3, where let's say, okay, let's say Sunil attended PML. He loved the concepts in PML. Sunil is going to apply them in his job. Sunil's job is essentially of a data scientist. He referred PML to his friend. Okay, so now how many times PML has occurred? PML has occurred 3 times, right? So let's say your PML term frequency is 3. Now let's say Ashok, Sharad, okay, Sharad has not talked about PML. So let's say Ashok, the director of MCAL, he says, who is more impressed with PML, right? So if he writes that query, who is more impressed with PML? So the query will check PML in each of the documents, and PML is 3 times here, but PML is 0 times in this doc. So the document will tell Sunil is, or let's say your document 1 is more praiseworthy of PML compared to his document 2. So Ashok will read that document and say that, okay, Sunil has more benefited from the program compared to Sharad, right? Just for an example here. So this is how we are trying to refine. So for example, if Sharad also had said at least once, right, still my document 1 will be more valuable to Ashok compared to doc 2. Now you can also ask me, how do I know Sunil has praised PML? I can also say he won't refer PML to his friend. Sunil is attended PML. He didn't love PML, right? So the context yet we have not captured. We have just captured the words and their importances. The context here we have not captured. Is it okay till now?
Yeah. Yes, Shabdip.
Okay. So now we all understand what are conjunctions or prepositions, right? So if I do this term frequency, it means the words which are more occurring in the documents will be more important. But a word like and, if, them, they, these words will be occurring most number of times in all the documents, right? If it is occurring across all the documents, then that word is not important to me, right? Because it is generic, it becomes generic. For example, if PML, don't consider that we are I mean, just forget the thing that we are considering we are not considering the context. If the context is not considered, if both would have said PML for 3 times, Sunil and Sharad both would have sent PML for 3 times, and if Ashok wants to say, see who refers PML more, then Ashok will not get the answer, because PML is more generic. It has become more generic from from the training. PML is occurring in all the documents. So for example, all the participants, if they have talked about PML, okay, so there are 5 participants, everyone has talked about PML and their sentences have PML in it. So PML becomes a generic word. It doesn't give importance about the candidate. Every candidate has spoken about PML. I don't want that word which is more generic. Everyone, everywhere it is present. Now, for example, Ashok wants to see who has really applied that, right? So apply may be occurring in Sunil's document twice, but it may not be occurring in other 4 candidates, right? So apply becomes a more important word, a word which is characteristic of a document, but it is not present in other documents. Okay, so how do we represent that in mathematically? So term frequency, okay, divided by document frequency. Okay, term frequency divided by document frequency. A large number of high number of term frequency is good, but if it is present in all the documents, then it is not good. So if I say this is the score of a word, so a term frequency divided by the document frequency is the score of a word. Now if the score of the word is high, that word is important to me. If the score of the word is low, that word is not important to me. Okay, now so essentially if my term frequency is very high but my document frequency, so let's say your term, let me write it here. So for example, your term frequency is high and your document frequency is low. It means it is present. I think there is a little disturbance in the line. Can everyone put yourself in the mute? I'm hearing a lot of disturbances in between. Anyways, so term frequency is high and the document frequency is low. It means that word is important to that document. If the term frequency is high and the document frequency is also high, it means it is a generic word. It is not important to that specific document per se. Any questions till now?
So what about the case in which a particular word is coming 100 times in a document,
Okay.
but only few times in all other documents?
Excellent. So that word is very important for that document, right? So if a document, understand this. Let's say okay, let's say there are 100 documents about World Cup. Okay, so recently the football World Cup came to an end, right? So let's say 100 documents containing the word World Cup, okay, in Google. Okay, now for example, if you want to see Cristiano Ronaldo's performance in World Cup, okay, now maybe only 2 newspapers or 2 documents were talking about Cristiano Ronaldo, right? So the term frequency of Cristiano Ronaldo in those 2 documents is very high, but it is very rare occurring in other documents, right? It means if you search Cristiano Ronaldo, those 2 documents should come up in your search. Other documents will not come up because it doesn't have Cristiano Ronaldo so much. It might have a simple mention or a simple praise about his hat trick, but those documents which have Cristiano Ronaldo more number of times are documents which are characteristically saying about Cristiano Ronaldo. But if you enter World Cup, every document will come 100 documents. So World Cup is not a generic. It has become a generic word for all the documents, right? It is not an important. It is not a characteristic word of all the documents. Do you understand this? So if a just think like this. If a word is more occurring in a single document, but it is not occurring so much in the other documents, it means this word is really important to this document. This document is really speaking about that person. This document is really telling me about that concept, whereas the other documents are not telling me about this concept, and it is also not a generic word. Okay, so
Sorry, but what about the case in which Ronaldo, assuming the first document, Ronaldo was playing from this country in World Cup, he was doing good and he has scored this. So here in the first document, Ronaldo has appeared only one time, but I am using he pronoun for him many times.
Yeah.
In the other document,
Tell.
In the other document, Ronaldo can come 2 or 3 times, but there is no he. So in the first document, I am referred Ronaldo many times compared to second document.
Okay, very good question. That's a very good question. So see, what we are doing here is slowly progressing in how to give intelligence to our words, right? So what I have said is we are right now at a point where we are discussing only about the term frequency. Slowly we will discuss about the unimportant words. Then we will slowly go on to how to include context. So here what
Okay.
you're seeing is something called context. So he is actually a pronoun of the same person that we started with the sentence, right? So slowly when we go on to different procedures, we apply these intelligence, or we also incorporate these intelligence to our upcoming models. But right now we are just doing a simple analysis, right? That's a good question. So what we here is what we do here is called dependency parsing. So a noun or a pronoun or a verb is actually dependency parsed. So there's a tree. So every noun, pronoun, verb, adverb will have a root name to it. So for example, he will be dependency parsed to Ronaldo. So then he will also be counted under Ronaldo. His will be dependency parsed to Ronaldo. That's why his will be counted under Ronaldo. So dependency parsing is another concept that we will come to it later, not now. Okay, but is this
Yes.
concept clear?
We can't share a screen, Shruti.
Yeah, I because I kept it. I think it whenever it automatically logs, right, it goes away. Maybe I'll just start. Can you see now?
Yes.
Yeah.
Okay. Okay. So so we have understood this part, right? Term frequency, inverse document frequency.
So in another way, if a particular word is coming in all the documents, we will keep TF IDF for that. Means for every document there will be, and sorry, for every document, for every word, we are going to keep TF DF. Am I right?
Correct. So now we have advanced here. So here Sunil was there, Sharad and all, everything was there. So initially what we were doing, we were just keeping it binary. Then we started with term frequency. Then now we are keeping TF-IDF. So the score of Sunil in document 1 is no longer 1 or no longer term frequency. It is now term frequency, inverse document frequency.
So is this the same matrix which we have modified? Am I right?
Yeah, same matrix,
Okay.
which we are trying to slowly modify.
Okay.
Okay. Okay. Now, okay, now let's introduce another concept called tokenization. What is tokenization? Tokenization is nothing but you have a sentence. I have iPad. I enjoy taking classes. So in Python, it is essentially a sentence, but I need to find out term frequency, inverse document frequency. I need to access each of the words, right? So first, what I have to do is tokenize. So I will be a token, have will be a token, A will be a token, iPad will be a token, I is already a token, enjoy will be a token, taking will be a token. Okay, so basically tokenizing each of the sentences. So for example, to calculate the term frequency, inverse document frequency, you need to have access to each of the words. So you tokenize, right? Then there's something called lemmatize. So what is lemmatize is basically if the word is take, took, taking, yeah, So each of the words are derivatives of take only, right? These are not different words altogether, right? So basically, if I have took, I should not consider this as a different word. This is essentially the same, just the past tense, but the same essence as take. Similarly, taking is the same essence of take, right? So lematize means you always go to the root word. Okay, so the root word is take. Okay, then there's something called normalize. What is normalize? Normalize is basically, let's say you have USA and United States of America. No TF-IDF matrix can tell you that these are the same, right? So Python has an inbuilt normalization dictionary where every, like some abbreviations, possible abbreviations are mapped to each of the full forms, right? So USA and United States of America is same. Similarly, all other abbreviations are kind of mapped in all together in the corpus, so that people, whenever they run a query, they don't have to mention. A person writing USA and United States of America should get the same query or same results altogether, right? So this is called normalization.
So can we
There's
think it as a synonyms?
sorry.
Can we think it as a synonyms or only means abbreviation?
Not only abbreviations. So for example, USA or U.S.A is also mapped. Okay, so it's not just abbreviations. So let's say automobile and car is mapped. Plane and aeroplane or flight is also mapped. Okay, so it's not just abbreviations, it's kind of the general words that people kind of use apart from the dictionary words.
Okay, means words having the same meaning or similar meaning.
Correct. Which they don't have any resemblance to it. So because plane and flight will not have resemblance in terms of any logic, right? It's just same. It's what people use as a vocabulary, right? So then there's something called okay, so normalization, lemmatization, tokenization. Now there's something called stop words. Stop words are basically words like and, or, if, thus, therefore. So these are the words that do not add any information to your query, right? Kind of prepositions and kind of, just trying to fill up sentences. So these words do not add any information per se to your query. So these words you do not want in your term frequency inverse document frequency matrix, right? So stop words removal is very important, right? So whenever, so this is kind of the, so all these words are all these things are kind of the pre-processing steps. Like we pre-processed our data, these are the pre-processing steps for NLP. You should remove. Okay, now should we remove the stop words first and then lemmatize, or should we lemmatize and then remove the stop words? Or is it the same?
First lemmatize and stop word. Should remove stop words.
First lemmatize and then remove stop words, is it?
Yep.
Correct. What is the reason?
If there is any other meaning, if those are there, if those words are there, like combining conjunction words.
Correct. So basically,
be
stop words are limited. I think there are 150 or so words that are present in the Python dictionary as stop words. So there may be certain cases of past tense, future tense, or some tense of these words, then that can be there present. So first, it is always essential to go to the root word and then remove the stop words. So there is a pre-processing steps
No,
of
it's
NLP.
not clear, Subhadeep. Subhadeep, that's not clear basically. Which one first and why?
Okay,
Stop
so
word
stop.
versus yeah.
So what I told is lematize, right? Lematize is, for example, let's say, okay, let me see. What example can I give? So for
These,
example,
those, we can, yeah, we can.
so for example, some stop words is there, okay, but your sentence contains R. R is not here. Does R give you any information about your query? No, right? Normally also, when you enter the query, do you even write the prepositions? You don't write, right? So just write random words like PML effect, courses in PML, okay? Or so very few times you write full or good sentences. What are the courses offered in PML online, right? Very few times you enter the preposition. So that's why these things do not add any information to the query or the extraction process. So for example, if any sentence contains R, first we go back to its root word is, and then is will get removed by stop words.
But it's a lemmatized, then a stop words.
Yeah.
Okay.
Okay, so let us get so I'm using these slides because these are very intuitive. Can you see my screen?
Yes.
Yeah.
Okay.
Yes.
So let's go back and let's see what we have learned first. So information retrieval is finding a material, usually documents, of an unstructured nature, usually text that satisfies an information need from within large collections. Okay. So if there are only 2-3 documents, then you can just manually extract. But if there are large amount of documents or collections, then you need to have an automated procedure to do that, right? Okay. So we have seen what is a document. Document can be web pages, email, books, news stories, scholarly papers, messages, PowerPoint, PDF, forum posting, patents, IM sessions, tweets, question answers posting, anything, right? So when essentially you write a query, your Google is going through all of these things. So I mean, I just appreciate that search engine which is doing so much, and people don't realize what it is doing in the background. I mean, I also never so there are many things that are very interesting in natural language processing, right? So understanding the context. Now even if you understand the context, then there's something called sarcasm, right? So that sarcasm context is very difficult to understand. So we'll come to that if we have time for in this session. We'll see how you understand context in what do you call information retrieval or NLP. Okay, so your database can be of bank records, balances, names, addresses, social security numbers, dates of birth, etc. But these mainly are structured data, right? So account numbers, balances, names, these are all present in Excel files. They are in structured data. That's why it's very easy to compare fields with well-defined semantics. So for example, if anyone says to find out this particular account number's information, then it's very easy, right? You just have to write the account number and there will be just one listing out of it, right? A simple search. So for example, if you're doing finding the records with balance rate greater than 50,000, you can just run an SQL query and it's very easy to do that. The challenge will come. Let's say, okay, it's not mentioned here. So we'll slowly go to the challenge. So what is IR? How do we do in IR? The indexing and retrieval of textual documents. Okay, so first we have to index, like what we have done is term frequency, inverse document frequency. We kind of index it and then we retrieve it. Okay, so first the concern is with retrieving relevant documents to a query. So as I've said, you cannot always run give me 1,000 documents back with my query, right? You have to refine your search. You have to give me the most important documents first and then the other documents. So there should be a rank, particular rank. That's how Google functions, right? So there are so many search results. It gives you the best results to you on the first rank, then comes the second, then comes the third, right? So you have to give me the better ones. Okay, so we have so for example, someone writes, what is the killer app? Okay, so there will be, if you go by the word killer, then there will be apps which are meant to kill, but the person who meant this query is not meaning to find apps meant to kill, right? It is kind of searching the apps which are revolutionizing, revolutionary in the sense, right? Which is kind of really appreciate. So this is where your understanding of the context is very important. Okay, now let us get back to, I think we have already told all these things too. So basically your document corpus is there, a lot of documents is there. Your IR system is the converting those documents to TF-IDF, then you have a query, and then you have a ranked documents. You always remember this. Okay, so what is relevant? Relevant documents contains the information that a person was looking for when they submitted the query. This may include being on the proper subject, being timely, recent information should be there. Okay, being authoritative from a trusted source, satisfying the goals of the user and his or her intended use of the information, right? So this is meant by relevance. What we have done is just address the first one, being on the proper subject, right? So we are trying to get the documents which are relevant to the subject. Okay, now let us go. So we will do a hands-on training. Since I do not have the laptop connection today, tomorrow we will do some hands-on and I will show you how your different extracts can, different queries can change the retrieval process. Okay, so all these things I've already told you. So see, People Republic of China versus China, right? So these are two essentially the same thing, automobile versus car. Here's where the normalization comes into picture. Okay, now there's something called retrieving the irrelevant document because of ambiguity. So Apple, now if you search Apple, okay, so whether it will return the fruit or the company, that's a very difficult problem or difficult challenge for the search engine, right? So you might search Apple and it gives you the fruit, but what you meant was to see the Apple company and vice versa also. So these are the challenges basically which natural language processing tries to address using machine learning. So how will machine learning help here? Any idea?
Based on context.
Exactly. So that's a perfect answer. So right now what we have done is kind of index date, term frequency, I mean inverse document frequency. But the question that Sunil had asked, right? How do we find the context? That's where the machine learning part will come. So bear with me, we'll slowly come to that. But just understand and appreciate the challenges. So if you, for example, enter Java, so Java can be a programming language versus an island. So which one to retrieve? Okay. So an intelligent IR system will take into account the meaning of the words. Okay. Adapt to the user based on direct or indirect feedback. Take into account the importance of the page. Okay. So and so on. So let us go back to the okay. Let us go back to the So this is what I was meaning with term document indices incidence matrices. This is basically the binary matrix. If it is present, it is 1. If it is absent, it is 0. Okay. Can anyone tell me what is the challenge here?
Basically, in 2-dimensional matrix, the
Okay,
number
but
of features or number of columns, that will be sum of all the words in each document.
correct, going right. Yeah.
So means logically it's tough to pass and operate on that. That is one of the challenge I can think.
Yeah, that is one challenge. But to explain it a bit further, is that a lot of documents will not have a lot of words, right? So your matrices will be very sparse, or let's say a lot of them will be filled up with zeros, and that is a space constraint, right? So if you have millions of documents and each document has like thousands of words, imagine the complexity of this matrix. It will be huge, and more than 70% of them will be zeros because many of the documents will not have many of the words. So that's a space constraint and a space wastage. So that is a very big challenge for uh, IR. Okay, so right now what we have, okay, inverted index, we don't want to see this. We have already seen the different thing. Okay. No need to go to the query optimization. Let's go to the pre-processing. Okay, so tokenization, we have already seen what are the problems. So Hewlett-Packard, if you tokenize, then Hewlett-Packard will be two different words, but essentially it is the same word that is connected, right? So it is Hewlett-Packard is a company. It is not two different words. State of the art. State of the art is combined word. It's not state of the art. It's not different words. So here tokenization is always not helpful. So it is very, so see, in information retrieval, this is a big challenge, right? So more you refine your query, more you will be precise to a specific thing, and you will lose generalization. So in context of machine learning, you're kind of overfitting here, right? tokenization, you're breaking the words so distinct that each of the words will lose its meaning, right? So you're losing generalization and you're trying to overfit. San Francisco. San Francisco is a kind of a particular state, right? It is not San and Francisco, different, right? It's kind of the same state. It doesn't have an hyphen in between even. So how will you understand that San Francisco should come together? So this all comes from the machine learning part, right? So machine learning will help you to understand that San Francisco will always come together according to the previous searches that people have done. So for example, imagine the first person searching San Francisco. Google might have told him some results of San and some results of Francisco separately. That guy got really frustrated, went down the pages, and then it entered into, let's say, San Francisco temperature, right? So Google understood that San Francisco was not meant to be San and Francisco differently. It is a combination of these two that has to be given a result of, right? So it is learning. Every time you enter a query in Google, Google is learning that what every user is trying to mean using its machine learning, right? So this is where we combine NLP and machine learning, right? So everything you cannot be like solved with term frequency, inverse document frequency, or binary matrices. The context learning should be done from machine learning, right? And how we will do that, we will learn. We will give you an introduction of how we to do that, right? Okay. Numbers is also a challenge sometimes. Chinese, how do we read Chinese? Chinese doesn't have white spaces. How will you tokenize it even, right? So any idea how you can tokenize it?
First it translate to English, then it might.
That can be an indirect way, but it's basically one of the logics can be like, slowly what you do is you even tokenize the word to letters, right? So each word will now be a comparison, combination of letters. Now each as you read the letters, you add the letters to the previous letter. For example, there's a word called, let's say, stop. Okay, so stop, right? You first tokenize stop, s, then you ct, then you add t to s, then you have st, then you have sto, then you have stop. So as soon as the word that makes sense, so stop will be a valid word, right? So you can check that in your English vocabulary. So as soon as the first word that makes sense from the English vocabulary sense, or let's say the Chinese vocabulary sense, you stop there. So you have tokenized the word. So first you tokenize the sentence completely, then you tokenize the letters in that, and then you start combining the letters and stop or give white spaces as soon as the word makes sense. Does it make any sense here? Do you understand?
No, Shobhit. Can you repeat that again?
Okay. So see, when we are tokenizing it, what we are doing in English is based on white spaces. We are separating the words, and right. So if the sentence is I am going to school, the tokenized thing will be I separately, because there was a space between am and I. Then going and am had a space. Then school. So essentially, because of the white spaces, I could tokenize the words, right?
Yeah.
Okay, but in Chinese there is no white space. How will you tokenize? So what you'll do, let's say, let's just think of an analogy here. I am going to school is continuous, right? So let me write it here. Let me draw it here for you. So let's say I am going to school is a single word. Okay, how will you do this? You tokenize this as single letters. Okay, I, A, M, G, O, I, N, G. Okay. So what you do is you take the first letter. Does this make sense according to the English dictionary? Yes, it does make sense. You have your word. Then separate it. Then you start again. A. Does it really
No.
make sense? A makes sense, right, in English?
Yeah.
So you get an error here. So basically, you have done a mismatch here. I mean, you should have gone with AM, but since A is there in English dictionary, so you can't do anything further here. Then you start with M. So M, does it make any sense? It doesn't make any sense, right? Then you start with MG. Does it make any sense? No, it will not make any sense. So MGOING, nothing will make sense. M will be replaced. Then you start with G. G, does it make sense? No. GO, yes, it makes sense. So you'll stop here. So there are many things that you have. Sorry.
It would be when we come to A, it should
Yeah.
check for A and M, right? AM.
Yeah, it should have. But the logic, what I am just telling you right now, will not able to support, right? So that's where you have to go to your machine learning. You have to see what is the combination. Does I and A come together even historically? No, right?
Yeah.
I and A will not come together historically. That's why A will be rejected there. But right now, what I was telling, depending on the words, which whenever it makes sense, you stop, it will stop here, right?
Okay.
So you have to give intelligence from machine learning that I and am will come together and not I and A. So that's where you can fill this.
Okay.
Okay.
Yeah. Thanks.
Any questions? Sunil?
Yeah, surely basically, it's clear means how we will search, but still I'm not able to figure it out how to use the machine learning in this one.
Yeah. So because you're not trying to figure out, because we have not told you how to do that, right? I'm just giving examples.
Okay.
Yeah. So
Okay.
we will use machine learning. We'll just give you a taste here, not go into depth in machine learning this because this NLP with machine learning. So we'll just tell you how we can use it. Anyways, so ambiguous. So we have already seen this. Other cases of no white spaces. Anyways, these are okay. Okay, there's something very important called case folding, right? MIT versus MIT will be different, but it should not be different, right? Fed versus Fed should not be different, right? So every letter should be converted to lowercase letters, right? So that's so that it makes sense to your query to match them. Normalization, we have seen what it does. Need to normalize terms in index text as well as query terms into same form, right? So example, we want to match USA and USA. They should be of the same class. Okay. So window and windows. Stop words, as we have seen. Examples are A, in, R, is at, B, by, for, from. So these are the words which do not make any sense. I gave an example of R and is there, but you see R is already there in. So slowly people are developing this stop words dictionary, right? So but still the concept still remains that whenever you first you lematize and then you uh, remove the stop words. So lematize, we have already seen what is lematize. Car, cars all fall under car, right? Destruction should be destroyed.
We should be using these lemmatization and stop words in our programming. or those will be available already just to use?
So lemmatization will be automatically done. Stop words will also be automatically done, but stop words has a dictionary, so you can also update your stop words according to the let's say use case, right? So
Yeah.
you might think that for your particular aspect, these are the words which are not important, so you can update your stop words there, right?
Okay.
These are the these are the general stop words in in generic cases, but you might be working with some case where other things may be stop words, right? So you can
Yeah.
update that manually
Okay.
also. I mean, not manually, you can update the
So these
dictionary.
will be available automatically when we use it in programming,
Yeah,
lemmatization.
yeah.
Okay.
So what is stemming? Stemming is a little let's say, what do you call, more naive approach to lematize. So instead of having different, let's say, automation, automatic will reduce to automat. Okay, so it might not make sense, but it is kind of taking out the root word out of this. The root word might not make sense. So stemming, normally don't use it, because if you're doing a lemmatization, that solves your purpose. Don't do stemming. But people, sometimes there are use cases where you can do stemming, but will not use that here. Okay, so stemming is crude heuristic process that chops off the end of the word in the hope of achieving what principal lemmatization attempts to do with a lot of linguistic knowledge, right? So stemming is more naive approach than compared to lemmatization. Okay, so we'll not go to Porter stem algorithm. This is basically Porter stem algorithm of lemmatization. Okay. Okay, so this is also done. Next, we will go skip pointers. Are you getting this? Are you finding interest in this? Because see, this is a very interesting topic, natural language processing. So much to do, so much to think about. So as I've said, there are, no one knows all the answers about natural language processing. Everything has to be thought about it. So tomorrow I will give you an example of the natural language processing I did in my project. And so, okay, let me give you an introduction about it. So my company has a lot of SQs, right? SQs means stock keeping units. So Johnson & Johnson has a lot of SQs. Let's say in a particular only Asia Pacific region, there might be 8,000 SQs, right? So 8,000 SQs will have, each of the SQs will have descriptions, right? So descriptions are like 20 grams Neutrogena face cream, okay, or Johnson's baby oil 60 grams, or Johnson's baby powder 20 grams, right? So what happens is, the ERPs are SAP based, right? SAP is a main transactional database that we have. Now there is a separate database where in Europe that had SQs of Asia Pacific, right? But while entering those SQs, people had not kept the same number. So for example, if a material, the same material has a number of, let's say, 1002 here, in Europe the same material may have a number different, completely different, like maybe 5067. How to match this? You just have the number which is different, you just have the material description. Now you consider each of the SQs as a different document. You find out the characteristic words from TF-IDF matrix of each of the SQs considered to be a document. You match these documents and you find out the best document rank according to this SQ. For example, Neutrogena baby face product 20 gram. I use this as my query. My document list is the SQs in Europe. Okay, I try to match this with each of the documents, and then I find out the most relevant document that comes up. You getting it? So a SQ description in Asia will be in my query. I need to find out the corresponding material number in Europe. So what I do, I enter that query. My search engine will essentially run through all the materials in Europe, match this query description with all the materials, and give me the best possible match out of those lists. I did this, and this has been so well appreciated that different departments are asking me to, apply this algorithm for their particular use case. That is the power of natural language processing. So many of the companies, I mean, you after we learn this, you just go into your respective companies, and you will have a different view of seeing words. Earlier you used to say, okay, words, how will I use that data? But now if you learn natural language processing, you can extract so much of it from just the descriptions or just the words out of your business. So for example, one other use cases.
On that particular example which you gave, so what you mentioned that each country has a different number, but they have the same description. So based on the description, you have matched those SQs, right?
Correct.
Okay.
So all the description will not be exactly same. If it is exactly same, then you can use an Excel based word matching, right? It is not exactly same. There is some similarity, some size may be same, some words may be same, but it is not exactly same. For example, Europe may say Neutrogena baby face powder 20 gram. Okay, my sorry, Asia Pacific may say baby powder 20 gram. Okay, so Neutrogena is not there. So you have to match it and score it and see whether Neutrogena actually makes sense. So Neutrogena, whether it is a characteristic word of this particular document, or is it so generic across all franchisee that you don't need. So for example, if all the SKUs are from Neutrogena, then I don't need Neutrogena in my matching, right? Even if Neutrogena is not present, it means that I can match the rest of it, right? So that's where your term frequency, invoice document frequency match will come up.
Does it will include that ounces search? Means in US they will search with ounces. Ounce.
Sorry, I didn't get your question. What were you saying?
No, that will include like 20 ounce powder, baby powder.
Yeah. So in US, the dimensions of measurement may be different. In Asia, it may be in grams. So you also have to take care of all that. So every problem is different. Unlike machine learning, what we have learned from structured data, you will use these algorithms and you get the best of it. Natural language processing is very different from it. You have to see the data, you have to understand it, what will make sense, what will help you tune your algorithm according to your requirement. It is not something that is present as such. So you just on Monday, you go to your respective companies, see the text data and see what you can do out of it, and you come back to me, message me that this is there. Can you tell me how we can leverage this data? So for example, right now, how people build chatbots. Chatbots is, for example, what we are trying to build is, let's say I have so many reports, right? So many reports across different databases, different matrices are there in the reports. So for example, it is very difficult for me to search manually and go each of the databases. And so I need a chatbot. I want to say that chatbot, give me the UFR, or let's say the forecasting accuracy report for 2017. It will search on its own and tell me the report. So how will it search? It will first convert my voice to text and then use that text to search the file names and give out the best possible match. Kind of how Google or Siri in Apple does, right? So it's how
One question on the chatbot. The chatbot is basically pretty much we can use it either on the text, like we can type something and it will give me query, and as well as it will convert from voice to text, right? Both.
Correct.
Both things are called chatbot, right?
Yeah.
Ultimately, in the background, it is using this machine learning techniques and an algorithm to give me the result, correct?
It is using natural language processing and machine learning both. It is not just using. So whenever there's text format, right? So all these processes, right? What we are trying to do, like TF-IDF, what I said initially is we are converting the words to numbers, right? So first you have to convert the words to numbers, and then you can do your machine learning problem. So what we have learned today is how to convert words to numbers.
One more question. So on high level, difference between machine learning and then natural language processing or a thingy that anytime there is a structured data, machine learning can be applied definitely, and in most of the cases. But if there is unstructured data or there is image or some voice and other thing, then probably machine learning technique definitely cannot be applied. Then we need to go for this NLP and these things, correct?
Yeah.
Okay.
Okay. Sunil, do you have any questions?
So basically, I'm something which I can grab from and related to NLP because I'm still.
Sorry, I'm not getting
on the okay. So basically, I'm not bothering with these things. What are the other problems basically? So okay, so I'm there that we have the metrics where NF, IDF we have calculated, but after that, how to correlate the machine learning, or means what next after that? I'm there still. Because these are the problems. These are the problems I can go through the internet and I can figure it out. So I'm stuck there. I want to see some code. Still, I'm struggling with what NLP is actually. Is that the search? Means I have a string, I have to search some document or something else. If this is, then how will I proceed and use the machine learning?
Okay. So for example,
we can take the example of 4 documents which you have created, 3 for me, 1 for Sarad. So from that, we can write some query and we can go step by step.
Okay. So for example, right now you have created documents as a vector of matrices, right?
Correct.
Okay. So now imagine those documents as the rows of your machine learning and those words as features. Okay.
Correct.
Now, what you used to do in machine learning, you used to form a model based on the features. You would want to predict if these are the words, what will be the result. Okay. Now let's say your different, let's say your document 1, let's say your document 1, 2, 3, there are 5 documents out of sports, 6 documents out of entertainment, 4 documents out of crime, and let's say 10 documents out of what else, TV shows. Okay. Now each of these documents will have each of these classes. Now think of this as a clustering problem or a classification problem. Okay. Now, so for example, first 6 documents, they have these words, their TF-IDF values are there. Okay. And you have the associated class as entertainment. Next 6 documents have the words TF-IDF is there. You have the class as, and let's say sports. Okay. Now, someone gives you a document. You convert that to a TF-IDF. First what you do is form a model out of it. So based on these TF-IDF values and these features, you have trained a model that if my input comes like this, I will
we can
output
find,
the class.
we can
Classification
find
problem.
the classification problem, how it will be.
Correct?
And based on that classification, we'll give the list of the documents.
Exactly. That's what we
But no, but in that classification problem, everything has been converted into number, but only one class we will get, isn't it?
No. So for example, that's what I'm saying. 5 documents are of entertainment, 7 documents are of let's say sports, 10 documents are of movies. Now you get another document. Now you have to classify that document whether it is sports, movies, or entertainment. So based on the TF-IDF score of the document, just think that document as a combination of features.
Sudeep, I think so I can't see your screen. Could you share and we can
I was
discuss
not
on that?
Yeah, I'll draw it for you. Yeah.
So basically on that, I understand that can be converted into classification problem. So left side we have the documents which are equal to one class, isn't it?
Okay, now so let's see. Document 1, document 2, document 100. This is your corpus, which are the features, and here you have TF-IDF scores, and this you have the class. So let's say these are the sports,
Okay.
movies, crime. Okay. Now someone tells you similarly, right? These were the rows in your machine learning. These were the features, and these were the classes. Classes were much lesser than the rows, right? So if there were 100 row items, line items, there were let's say 2 or 3 classes what we are seeing. Similarly, there are 100 documents, and each of the documents are either sports, movies, or crime. Now someone gives you a document 101 which has the TF-IDF scores. You have this model ready. Okay. Use this model to predict which class your TF-IDF score falls into. I mean, which class it falls into.
So based on that, we will determine the class.
Correct.
And we have marked. So for 101, we have marked, okay, this is the crime movie.
Yeah. For example, based on the TF-IDF scores, it will tell whether it is crime.
So assuming for timing, it's crime we have calculated, and we have marked in our matrix.
Correct.
So now someone is coming to search.
No, see, searching is okay. So let's say you come up with a search, you come up with a query.
Correct.
Query is also a kind of a new document. It is not so much populated as a normal document, but it is kind of a document, right? So you feed this query into your model. The model will predict that based on these TF-IDF scores, which is the document it is talking about, or which is the class it is talking about.
Okay, sorry, I'm not getting it. So assuming we have 4 documents, 3 for me, 1 for Saraji, we have given some text. Based on that, we can create this one. Now 1 for Vashant we have created, and we can say, okay, this is also for MCAL machine learning. So that is a class machine learning. So if I am giving some query, so what can I expect out of these 5 documents? 1, 2, or 3 documents can I expect? Am I right?
So when you are giving a query, what you have to expect is the most relevant document should come up first, followed by the next relevant, followed by the next relevant. Okay. So if you are talking about Sunil, Vasant, Sharad, all of them have learned PML, and you search a query on PML, just saying just stating PML, then all the documents will come up, right? So the computer is not wrong. Everyone has learned PML. You have not given him any other information to tell what is the statistics. Let's say if you want to say liked PML, right? So out of these 3 people, 2 people have liked. So based on that query, the document, the query will be fed into the model. The model will tell you whether they have liked or not. So liked or not liked is a class there.
Yes.
Understand? So supervision has to be done. So for example, Sunil's comments. So for example, Amazon reviews, right? So Amazon reviews, how it, how Amazon will extract features from your reviews. So for example, Sunil has commented on Amazon. He bought an iPad. He liked it. Okay, and he has given 5 stars. Similarly, Sharad has gone to Amazon. He bought the same product, iPad. It is slow, heats up. So your star rating for him is just 2. Vasant has gone to Amazon. He bought an iPad. He says it is better than Surface, Microsoft Surface. He has given 3 stars. Now, being an Apple company, what I'll do is I'll go to the reviews, convert all of them into TF-IDF matrix, keep the ratings as the values, okay, keep the ratings as my output or the outcome y variable, right, and run an algorithm, and then I will see which are the features that are important, like we saw in our machine learning. Crime rate was important. Here also I will see light is more important. Heating up is important. Heating up is important because it is leading to a negative review. Better than surface. Surface is an important word because there is comparison. So you just have 3 reviews here, but imagine people giving thousands of reviews. You will get which are the words that are more important, that are leading to higher rating. So that's how you analyze your data, right? That's how your machine learning comes into picture. So for example, your rating will be the supervision, your words will be the features, and the users will be the rows. So based on this, you'll do everything that you were doing in machine learning. You will find out the important variables. It will give you an essence of what are the important words that are linking this to the rating, how consumers are rating this to the linking this to the rating. Okay, apart from that, you will see if you write a comment, right, I want to or let's say if you just enter another user and write a review, right, like um, those Surface Microsoft Surface battery life is very bad, and then you would see what is the relative rating of your if you enter this, that if your battery backup is better than Surface, then you'll see how better your rating will become, and that's how you can work on your battery life to make it more better than Surface. So that's how people will analyze the natural language processing data. So natural language processing is a whole umbrella under which first you have to convert the words to numbers. So what we have learned is just to convert the words to numbers. After you convert the words to numbers, then you can apply your machine learning models, right? You cannot directly apply the machine learning models to words, right?
Yes. Yeah,
So
I
does
think that's great. So,
yeah, so
I
does
think
this
I can understand now. Yeah, correct.
yeah. So because features already, the words had numbers, so you never had to do anything, but words don't have numbers in them. So first you have to understand how to convert that into numbers. That is how your natural language processing part will come, right? Then I mean your processing, your text processing or text mining will come. Then you'll go on to machine learning models. Now, machine learning models will give you a particular accuracy for unstructured data, but they are very good for structured data, but for unstructured data, you basically have to apply deep learning concepts to get the best out of it. So that's when NLP and deep learning are combined. So deep learning is applied on NLP databases, and then the best is extracted out of it. That's why we learn NLP and deep learning together. Okay.
Okay, got it. Sure, surely, if someone is asking what each NLP, we need to describe in such a way that means whatever the language we have to correlate, and then we have to retrieve the text based on some query. Is that the correct?
No. Retrieving the text is not so. See,
retrieving the document basically another way. Yeah.
Retrieving the document is information retrieval. That is different. See, like what I told about Amazon reviews, did they retrieve any document? They didn't retrieve any document, right? They analyzed the documents, right? So natural language processing is the process of, let's see what Google tells. That will be better to understand. Let's see what natural language processing definition does Google tell. The application of computational techniques to the analysis and synthesis of natural language and speech. What TF-IDF is synthesis. The analysis is the part of application of machine learning on it. Do you see?
Okay. Correct. And why speech means voice recognition also comes in NLP or in deep learning?
No. Voice to text is deep learning. Text to numbers is NLP. Numbers to analysis is deep learning again.
Okay, got it.
Okay. See, that's why. So it's beautifully explained, right? Analysis and synthesis. Unless you synthesize, there's no analyze. You see this word, Cloud?
Yes.
Okay. Now let's get back to our slides.
Is there anything which we are going to cover in NLP today? Otherwise, I have a few questions related to machine learning.
Yeah. It's still not over. We are.
Okay.
Yeah. Okay. Now. So just to be knowledgeable about it, when we did a incidence matrix or the binary matrix, we used the Jaccard coefficient to match. So for example, what is Jaccard coefficient? Is basically A intersection B divided by A union B. The number of words that match divided by the total number of words. That is basically Jaccard coefficient. Okay. Now, Jaccard coefficient, we have seen that it doesn't consider term frequency. Okay, now we had seen the term document count matrices. See, you have seen the term document count. Bag of words is okay. Term frequency is seen. Long frequency, log frequency. You don't need to wait this. Document frequency. If we continue, then we have the IDF, and then we have the TF-IDF. Okay. So don't go by the formulas. So basically, whenever we are scoring the query of the document, it is kind of the TF-IDF scores summation of all the words in the document that match with the query. So if you see this, sigma of the terms, T is the term, belonging to the query intersection document, all the terms that are present in the query, that are present, all the terms of the query that are present in the document. So if your query is online classes in PML, it will only score these words and find out the best possible document. Okay, summation of the individual scores. Okay, so this is how your TF-IDF matrix will look like. So for example, Antony, Brutus, these are the words. So they have just done a transpose. We have talked about documents on the left side and the features on the top. They have done the documents on the top and the words on the left, right? So this is how your feature vector will look like. So every word is now converted to a number. Okay. Okay, now if you guys remember, if you guys remember clustering, now what were we doing in clustering? So a very important part is clustering of documents. For example, right now I told that these are the documents that belong to sports, these are the documents belong to crime, these are the documents belonging to entertainment, right? Now for example, if you want to cluster these documents, Snohan has told you, you can also do that in NLP. So once you have converted the words to numbers, then it is very easy sailing for you to convert, to use all the machine learning techniques that we have done. So now if we are doing machine learning also, then we can use the unsupervised learning. The only thing that we have to keep in mind is the distance measure that we have to select. In clustering, if do you guys remember what was the distance matrix we were selecting in clustering?
Are you discussing about k-mean clustering?
Yeah.
Means we are giving the k, and based on that we are randomly selected. Then we are getting the average until that mean that is coming is not constant.
Correct. That is algorithm. You're correct. I'm asking, what was the distance matrix? What was the x1 minus x2 whole square plus y1 minus y2 whole square? Remember that?
Yes.
Some root mean square.
Root mean square, you mean?
Yeah, root mean square. Yes. So instead of that root mean square, we have to use the cosine similarity in this, or the cosine distance. So I'll not go into depth of this. So when if you guys are interested into NLP, when we start that course, we'll go into depth of what is the cosine similarity, on what is, how we can use cluster the documents based on k-means clustering. You can do a k-means clustering on the documents. You can do a hierarchical clustering on documents. Okay. See, if there are two concepts, just to give you an example, rich is one feature, poor is one feature. Okay, let's say classes. So based on the angle, the closer the angle to the class, that's where it gets clustered. Okay. Okay, so this is all mathematical, no need of this. Okay, I think we can close NLP for today. You guys have any questions on machine learning? We can discuss that.
One,
Sorry.
can you send that iPad file? This thing.
Yeah, the notes, right? Yeah, I will send you. I'll send you.
Just post it into that same thing. And also the last week, last week lecture was also not posted.
Yeah, the problem is, I think what happened is the video did not get converted. So after the Go team meeting ends, right, the video should get converted. The video did not get converted in my machine. So, sorry?
For both days, Saturday, Sunday, both?
Yeah. So, so there was an update issue in my laptop. So today, today or by tomorrow, I will post both the lectures and this week's lectures also as we happen.
That's
yeah.
So can we see code around this one NLP sometime?
Yeah, we can. I will show you, but the machine learning code is not there. Yeah, machine learning code is not there, but the document similarity, TF-IDF, word limitizer, everything is there. My laptop is not opening. I mean, I'm not connected to my laptop today, so that's why I cannot show you. Tomorrow, I have that
we can see
in my
tomorrow.
mind to show you the code. I have that code ready with me.
Okay, that's great.
Yeah, so you had some question on machine learning.
So I was going, what is this confusion matrix?
Okay.
One question. Another question, although we have covered basically confidence versus accuracy. So accuracy, that is clear. But confidence, I was not getting using any library. So that is the second thing. Third thing is, one was parametric machine learning, another one is non-parametric, as I remember the correct name.
Correct.
Parametrization or parametric, that was the name.
Parametric and non-parametric approaches.
Correct. So these three things basically it's not clear.
Okay. Confusion matrix, I think we spent half a class explaining that, I think.
Yeah, I remember, but...
Oh, yeah, okay. So I think you have forgotten. Let me see if I have the notes there. Okay, confidence and accuracy we have. Okay, anyways, I think I have to search for that. Okay, so confusion matrix, okay, I'll explain it again. Okay, let me ask anyone. Does anyone remember the confusion matrix? Does anyone remember? Doesn't ring a bell? We discussed this, right? Can you guys hear me?
Yes.
Yes, we can hear you.
Okay. Yeah, so I'm asking,
we discussed positive, negatives.
Okay, no problem. But it's good that Sunil, you have got that because confusion matrix is a very important concept, and you don't want to leave machine learning without learning this. Okay, let me draw a better table for better. So your model, a confusion matrix is basically a way of checking the accuracy of your classification model. Okay, like we have RMSE for linear regression or the regression per se. Classification should also have a accuracy matrix, right? So confusion matrix is kind of a table that is being used to check the accuracy of your classification model. Predicted positive. So let's say out of 100 actual positive, you could predict 90 correctly, 10 wrong. Similarly, out of actual negative 20 negative, you could predict 5 correctly, 15 wrong. This is your confusion matrix. So this is your actual truth. How many of them actually were positive and how many of actually were negative? Predicted is 90 is positive. Out of 100, you could predict 90 positive correctly. 10 you predicted them as negative. Similarly, for actual negatives, you could predict 5 of them correctly. 15 of them you predicted wrong. So these are called true positives. This is called false negative. This is called false positive, and this is called true negative. Makes sense? True positive means you have predicted positive. False negative is you have falsely assigned that to a positive to a negative. False positive means you have falsely assigned a positive to a negative. True negative means you have truly assigned a negative to a negative. So your overall accuracy is this. How many you have correctly classified, how many you have incorrectly classified out of the total, sorry. How many you have classified correctly out of the total. Does this make sense?
Okay, so just one thing. So this first row, second column.
First row, second column.
Yeah, actual positive means that should come in some category X, assuming, but we are not predicted in that category. Is that
correct? No. So for example, assume this as a binary classification, first of all. So binary classification, let's say you were predicting yes, no, or high, low.
correct?
So out of 100 high, you have assigned 90 of them, you have assigned high, but 10 of them you have predicted as low.
You have predicted as low, but those are high. Am I right?
Correct.
Yeah, correct. Out of 100 positives, correct. Yeah, I think so. I was asking the same thing.
Okay.
Okay, now
So this makes
So this is a confusion matrix, and what does it show? Does it show the accuracy, overall accuracy? Yeah, correct.
Now,
okay, got it.
I also discussed that overall accuracy is not a good measure to keep. Can anyone remember why? I told you F score, geometric mean, all these things we have discussed, right? Someone even asked a question, if it is 100%, 100% overall is the geometric mean, sorry, harmonic mean, F score was harmonic mean. We have discussed this in very good detail, right? What was the problem in overall accuracy? Why we should not use overall accuracy?
It's I think you mentioned that if it is a really 100%, it is overfitting, something like that.
No. Okay. Imagine you have a data set where 95 of them are positive and 5 of them are wrong. Sorry, negative. So out of 195 are positive and 5 are negative. Your actual database. You predict all of them positive. What is your accuracy?
100%.
No, your accuracy not 100%, right? Negatives were there. You have predicted everything positive.
Oh, so it is 0%, right?
No, 95 were positive. You have predicted 100 positives. What is your accuracy?
97.
Exactly. 95% is your accuracy, overall accuracy, right? So TP is 95, TN is 0 divided by 100. So 95% is your overall accuracy, right?
Your screen share was lost.
Sorry. Automatically gets. Yeah, so TP plus TN is 95 divided by 100, correct? Are you guys with me?
Yes, so 95% will be the accuracy.
Correct. But you have predicted all negatives wrong. You have 0% in negative. Imagine a database where you have to predict who are defaulting in a credit card. Do you think out of 100 people, 95 people will be defaulting? No, right? 5 people will be defaulting and 95 people will not be defaulting. And you say your boss, I have predicted 95 people will not be defaulting. I have predicted them correctly. I am 0 at predicting who are defaulting. Your boss will say this is not utter nonsense. I don't want to predict people who are not defaulting. I want to predict people who are defaulting, right? So this is where your imbalanced data will affect your accuracy. If your data is imbalanced, if it is too much one-sided, one class is overly populated compared to the other class, then you, whatever you do, if you predict all of them as positive, still you will end up at a very good accuracy. But is it the true picture? No, right? It's not the true picture. Out of 5 negatives, you could absolutely predict 0. That is bad, right? You don't want to have an algorithm which predicts only one class, right? So that's why we introduce something called sensitivity and sensitivity and specificity. Out of the true positive and false negative, I mean, out of the actual positives, how many could you correctly classify? That is your sensitivity. Out of the actual negatives, how many you could classify as actual negatives is your specificity. So for example, the example I was talking about, so your true positive is 95, your false positive is so actual is 95, this is 0, Actual negative is 5. You have 0. You have 5. Okay. So predicted positive. So out of 100, out of actual positive, you have predicted positive 95. Sorry, I think, yeah, correct, right? Out of actual actual 95 positive, you have predicted for 95 positive. Excellent. Out of negative 5, you also predicted 5 positive, right? That is totally wrong. So your overall accuracy will be still 95%, because 95 plus 0 divided by 100. But what will be your specificity? Okay, let me denote this for your better understanding. Yeah. What will be your specificity? Just see the formula and tell me. This is the formula.
95. Yeah, 95 first is.
Specificity. Tell me the
95 by
specificity.
100. That will be 0.95.
Yeah, 0 by 95 will be 0, right?
0. Sunil, you have to see the
Yeah,
formula,
sorry,
right?
TN. Yeah, sorry, TP I was looking for. TN, that is, yeah.
Yeah. So specificity is 0, absolutely 0. What is your sensitivity?
95.
95.
100.
95%.
100%. So one you are very good at, one you are absolutely bad. So you need a combination of these factors to give you a better score. So F score is the harmonic mean of sensitivity and specificity. What is the harmonic mean? What would be the answer of this?
Cannot be determined, right? Because 1 by...
Yeah, so this is kind of a infinite and this is kind of a 0. So F score will not be allowing you to go one. I mean, you be best at one thing and you can be 0 at one thing. It doesn't allow. Let's say it is 0.01. What will the value for this approximately? So this is, it will be very close to 0. You can just calculate. It will be very close to 0. Let's say if you want to check, 1 by 100 is 0.01 plus 1 by, this is 100. So 1 by 100, 0.01, right? So this will be 0.01, sorry, 0.01. So 0.01 is your accuracy. So even if one is 100%, other is 0.01%, your actual score, F score will be 0.01. So you have to be very good at both. Only when both are 100, then you will be getting your 100% accuracy, right? So if someone asks you what is the best metrics to measure your classification problem, you should always say F score. Okay.
Yeah, that's great. Sudeep, you are really very good.
No problem. These are very basic issues. No problem. Okay. Other answer question you had, class confidence interval versus accuracy, right?
Yes.
Okay. So for what you wanted to check confidence interval, you said that I could not check the confidence interval.
No, no, that was confidence versus accuracy. So accuracy, I was doing one example there. It was saying, okay, 98% accuracy I got,
Correct.
but confidence I couldn't get. Okay, how much confidence it was not giving me.
Okay. So normally all the algorithms are designed to operate on a 95% confidence interval basis. So for example, all the algorithms are pre-designed to operate on a 95% confidence interval basis. So whenever you have that object of decision tree, or if you go into the depth of these parameters, you will find the confidence interval. And if you don't find, then it is, if that object doesn't find, then that object is not statistically dividing the data. It is dividing on the basis of probability, right? So it may happen that all the objects do not give a confidence interval. For example, a linear regression will definitely give you a confidence interval because it depends on the mean and variance, and it assumes a distribution of the parameters. But a decision tree will not have parameter itself, right? It's a non-parametric approach. So if it is a, like I said, if a model is a process, it is, linear regression is a model of parameters. Y is equal to beta naught plus beta 1x plus beta 2x. But a decision tree is not parameterized, right? It does not have parameters like beta 1, beta 2. It is a process. A particular test comes, it flows through the trees, and the output is given, right? So it's a process. So if you don't have parameters, it will not have the confidence intervals associated with it. Okay, so every model will not give you a confidence interval, but on but on the whole, every model will, whichever is assuming a distribution of parameters, will operate on a 95% confidence interval basis.
Okay.
Okay. What was your third question?
Parametric versus non-parametric.
Parametric and non-parametric, I think I have already explained just now. Parametric is the model which has as an equation form. Can you tell me the equation of a linear regression? Yes, you can tell me by the slopes and the signs. You can tell me this is the equation of y is equal to beta naught plus beta 1x plus beta 2x2. Okay, can you tell me the equation of a decision tree?
No.
No, because it doesn't give in an equation. It is a process. It is kind of
Random
building a
forest,
tree.
we can't
Random forest is also a process. K nearest neighbors is also a process. There is no particular equation associated with it. Okay, so it doesn't have parameters.
Okay, got it. Thank you. Thanks a lot, Surdeep.
Okay, no problem at all. So any other questions?
So what are basically related tomorrow? We are going to cover important topic deep learning. So what are we going to cover tomorrow?
So tomorrow we will cover very basics of deep learning. Why deep learning? What are the advantages of deep learning over machine learning? And what are the different algorithms that you can see in deep learning? So very basic approach. Yeah.
Means
So,
different, at least different algorithms we will go, not in depth, but by name or with some definitions.
yeah, just by name we will go, not in depth, because each of the algorithms will take a different class. So the algorithm. So just taking a feedback from you guys. Do you guys want to go into deep learning and NLP as a different course? I'm just asking you guys.
So not in NLP, but definitely I'll be interested in deep learning.
Okay. What about other guys?
Why? So why I don't know, but
No. I'm asking about other. Vasant. And...
Yeah. I'm interested in NLP.
Okay.
But NLP is dependent on deep learning, or both?
So as I said, I mean, NLP you can learn independent of deep learning, but that will not be much useful for you, because NLP, and to get the best out of NLP, you have to go into deep learning.
Okay.
So probably if you guys are interested, so if let's say that was my particular objective for the question, is that, let's say for example, you are interested in NLP, Sunil is interested in deep learning, and let's say some other guy is interested in both. So maybe I can talk to Ashok and have an integrated course so that both the things are taught. And so for example, 3 classes we have NLP with deep learning. I mean, 3 classes, first we have deep learning or normal machine learning things, and then 3 other classes we have NLP and deep learning. Or if you guys want, we can have separate NLP and deep learning, and then a separate deep learning. That also we can have, but that will I have to discuss with Ashok. So what about who answered? Sunil, after that, who answered? I could not recognize your voice. Vasant. Yeah, Sharad, what about you?
For the timing, I would like to absorb concept. So probably.
Okay. Great. That is also, I think, a good option to do. So for example, if you get more practice and get more hands-on on machine learning first, and then you can go on for deep learning, that is also a good decision. So let me talk to Ashok. So Vasant, you would like to just have NLP. I don't want to go into deep learning much, but maybe if you go tomorrow, if you see tomorrow, and maybe your interest might change. Let's see.
Right.
Yeah,
You're right. Yeah, I will decide tomorrow.
Yeah, but I think deep learning is more important compared to NLP, because NLP is still a more research field. People are still trying to get the best extract out of it. But deep learning is kind of little matured now. And so now that you have learned machine learning properly, deep learning will make more sense to get applied on the structured data and get the best out of it. And then so for example, boosting and all, whatever you have done, deep learning is a step ahead of boosting in some cases. I would not say in all cases, but in some cases. And if you combine NLP and deep learning, I mean, it's just a different world. You can do wonders with it. So anyways, that's something we can discuss later.
A genuine question. So NLP is more related to data, right? It is more related to data processing, and then deep learning is the algorithm, right?
Yeah, so for example, what we saw in the definition of NLP today, right now, so what we saw is synthesis and analysis. So synthesis is NLP's most complex area, right? So enough structured data, you don't need to synthesize the data much, right? So you already have the data in a structured format. You just need to get some cleaning, and then you can apply your models. But in NLP, your structuring and synthesis very important. So once you have that ready, then your algorithms can go. But if your structuring and synthesis is wrong, then God will not able to save the model, right? So I mean, deep learning is very small in front of it. So natural language processing, a lot of things go into the synthesis part, how to make your data more meaningful. So for example, how to extract the context out of so context extraction is called something called a word to vec. There's a model which employs deep learning and tries to synthesize natural language processing and get the context of the sentences, right? So deep learning is an essential part where deep learning is also used to synthesize natural language processing. So it's very, mingled. It is not two separate entities. It's mingled, but natural language processing as a whole is the synthesis of text data. Does that answer your question?
Yeah.
Okay. Okay, then we'll close for today then. I think tomorrow is the last class, so I'll definitely miss these hours we spent with each other learning and discussing so many things. Looking forward to have more interactions. Tomorrow will be the last class. Let's see. I think we'll end it on a good note.
Okay.
Yeah.
That should be
So
good.
thanks a lot, Sudeep.
Thank you.
Good night. See you
Yeah,
tomorrow.
thank
Bye.
you so much. Yeah, good night, everyone. Bye.
Good night.
Good morning, actually. Yeah, bye.
Sure.